key concepts in statistics. One of the most fundamental concepts in statistics is the distinction between a population and a sample. The population represents the entire group that you're interested in studying or drawing conclusions about. This could be all customers of Amazon, every voters in the United States, all smartphones manufactured in 2024, every student enrolled in college worldwide. In an ideal world, we might want to collect data from every single member of our population. However, this is usually impractical or impossible due to constraints like time limitations, budget constraint, physical impossibility, destructive testing if testing requires damaging the product. A sample is a subset of the population that we actually study. It's meant to be representative of the larger population. Examples include 2,000 randomly selected customers or a poll of 1,000 likely voters across all 50 states, 500 randomly selected smartphones from the production line, a survey of 10,000 college students from 50 universities. Why does it matter? The relationship between your sample and the population is critical for several reasons. So first, our goal is for the sample to represent the population accurately. Representativeness: for your statistical conclusion to be valid, your sample must accurately represent the population. If it doesn't, you will end up with a biased result. And practicality: studying samples is often the only feasible approach. For instance, a political poll cannot possibly survey all 240 plus million eligible voters in the US. And cost and time efficiency: collecting data from samples is significantly more economical and faster than attempting to study the entire population. And statistical inference: the whole point of sampling is to make inferences about the population based on what we observe in the sample. Let's see some examples. Consider the first example. If an e-commerce platform wants to understand customer satisfaction, they cannot feasibly survey all 300 million customers. Instead, they might survey 500 randomly selected customers and use statistical method to estimate overall satisfaction levels. And second concept is parameter versus statistic. This distinction follows directly from our understanding of populations and samples. A parameter is a numeric value that describes some aspect of a population. Parameters are what we are ultimately interested in, but they are often unknown and need to be estimated. Examples include the true average income of all subscribers or customers, the actual percentage of all cars with a specific defect, or the real median age of all specific social media platform users. We typically denote parameters with Greek letter like mu for population mean or sigma for population standard deviation. A statistic is a numeric value calculated from a sample. Statistics are used to estimate population parameters. Examples include the average income of 1,000 surveyed respondents, or the percentage of defects found in 500 inspected certain car manufacturer, or median age of 2,000 surveyed social media users. We typically denote statistics with Latin letter like X bar for sample mean or small s for sample standard deviation. The key relationship is that we use statistics to estimate parameters, which are unknown, but what we really care about. Bias is one of the most important concepts to understand in statistics because it can completely undermine your analysis. Bias refers to systematic errors that cause your samples or result to consistently deviate from the truth. Unlike random error, bias pushes results in a particular direction, making your data unreliable or misleading. Think of it this way. If random error is like noise and that can be reduced by increasing sample size, bias is like a broken measuring tape that will give you the wrong measurement no matter how many times you use it. So there are three types of bias. First, sampling bias. Your sample doesn't represent the population. And response bias. Survey respondents answer inaccurately or dishonestly. And lastly, measurement bias, when tools or methods skew the data. So let's look at the examples. So surveying only customers who visit the website during business hours and excluding night users is a sampling bias. Asking, don't you think the product is great? Leading questions encourages positive answer, which is response bias. And lastly, recording call center wait time starting only when the agent picks up, underestimating the actual wait time. It is a measurement bias. This occurs when the tools or methods of measurement systemically skew the data. And variable in statistics and data analysis, variables are the building blocks of any data set. A variable is any characteristic, number, or quantity that can be measured or categorized and that varies across individuals, items, or over time. If it can change or differ, it's a variable. Variables are building blocks of any data set, helping us to measure trends, identify relationships, predict outcomes, and group the data. So there are types of variables. First, quantitative and qualitative. As we discussed earlier, variables can be quantitative, which means it's numerical values, and it can be qualitative, which is categorical value. But also there are binary variable. This means that the variable has only two possible outcomes, yes or no, or true or false, and pass or fail, customer or non-customer status. Example includes whether a customer made the purchase, yes or no, or whether a student passed an exam, yes or no. And independent and dependent variable. This distinction is crucial when examining relationships or conducting experiments. First, independent data, a variable that you manipulate or observe to see how it affects another variable. It's the potential cause or influencer. Examples are price changes, marketing campaign exposure, or medication dosage. Dependent variable. This is a variable that is observed as the outcome or result. This is what you are trying to predict or understand. Examples include sales volume, click-through rate, patient recovery time. For example, in an experiment testing how price affects sales, price would be the independent variable and sales would be the dependent variable. Variability. Variability refers to how spread out or dispersed data points are within a data set. Variability describes the extent to which data points differ from each other. It's a fundamental concept because real-world data is rarely uniform and understanding spread is as important as understanding center tendency. Low variability means data points are similar to each other, and high variability means data points are inconsistent. Example, even when people buy the same product, their purchase amount, satisfaction level, or time spent in store may vary. If three customers spend $10, $50, and $120 on the same toothpaste, there's a high variability among the amount. Standard deviation. Standard deviation is the most commonly used statistical measure of variability. Standard deviation is a numerical value that represents how far, on average, each data point is from the mean of the dataset. It's essentially the average distance from the average. A low standard deviation means data points are gathered around mean. A high standard deviation means data points are spread out. So the formula for calculating standard deviation involves finding the mean of the dataset, calculating the difference between each data point and the mean, and squaring those differences, and finding the average of those squared differences, taking the square root of the average. Let's compare two classes that took the same tests. Class A scored 70, 72, 68, 70. So the mean is 70. Each score is very close to the mean. Standard deviation is really low here. But on the other hand, Class B, their scores are 55, 93, 32, and 100. So the mean is like for both are same, 70, but Class B scores are widely spread from the mean. It means standard deviation is high. So they tell very different stories even though both classes have the same average score of 70. Class A shows consistent performance across students. Class B shows extreme variation, with some students excelling and others are struggling. This example illustrates why looking at average alone can be misleading. Standard deviation provides crucial context about the distribution of data. Summary, let's review the key concepts we covered today. Population, entire group under study. Sample, subset of the population. Parameter describe the population and statistic describe the sample. Variable is any measurable attribute, and bias is systemic deviation from the true value. And standard deviation measures average distance from the mean.